Hello students. So in today's lecture, we are going to continue with the back exercise of chapter 8 motion. Now we have already done 5 questions in the previous 2 lectures. In this lecture, we are going to start with the 6th question. So first I'll read here. Listen to me carefully. This figure shows the distance time graph of 3 objects A, B and C. Study the graph and answer the following questions. Which of the 3 is traveling the fastest? Are all 3 ever at the same point on the road? How far has C travelled when B passes A? How far has B travelled by the time it passes C? I'll read the question once again. Now this figure shows the distance time graph of 3 objects A, B and C. Study the graph and answer the following questions. So first let us have a look at this graph. This is distance time graph, okay, of 3 objects A, B and C. So this graph is for A, this graph is for B and this graph is for C. So there are 3 objects in motion and here 3 graphs or graphs of the 3 objects, that is distance time graphs, are represented on the same graph paper. Study the graph and answer the following questions. So first let us study the graph and then we'll read the questions and answer to them. Now see this, time is in hours, distance is in kilometers, okay. Now here this, when we see A object starts from this, and I have not drawn the small boxes here. If you see the boxes, it will be, there are 4 divisions between 6 and 8 or 4 and 6, 0 and 2. There are 4 divisions. It means one division value will be 0.5. So here, this is just one division above 6. So it is 6.5. Okay, I'll tell you. Now first of all, you should see the graph, you should see the axis. Here it is already mentioned that this is a distance time graphs of 3 objects A, B and C. Even if it is not mentioned, you should read the graph and you should be able to know what graphs are represented here. So first thing is distance time graph, distance in kilometer, time in hours for 3 objects A, B and C. Now here, this A object starts the motion from here, okay. It means already it is some distance away from the origin. Maybe during the motion, one place was considered to be origin and this A car is already some distance away from the origin. How much distance away from the origin? Now see, between 6 and 8 or on this distance axis, 4 divisions make 2 kilometers. I have not shown it here. 1, 2, 3, 4. Then we have 2. 1, 2, 3, 4. Then we have 4. 1, 2, 3, 4. Then we have 6. 4 divisions make 2 kilometers. This is the scale for distance axis. It means one division is, yes, one division is, if 4 divisions make 2 kilometer, one division is 2 by 4. And 2 by 4 is half, that is 0.5 kilometers. So this A object starts from one division above 6. It means 6 plus 0.5, 6.5 kilometer away from the origin. If we look at this, the graph of B object, it starts from O, that is origin. It means it is at 0 kilometer distance away from the origin, or it is at origin only when the motion started. C object is at this point, okay. C graph starts from here too. It means C object is 2 kilometer away from the origin. So first of all, you should be able to tell what type of graphs are these, what are the units used, and the 3 objects start from which position. Now, the 3 graphs are straight line graphs, which clearly shows, we know that distance time graph is a straight line graph. We have the knowledge. We have seen the uses of graphs. So from the nature of graph, we can say about their motion. As the three graphs are straight lines and the distance time graph is a straight line for uniform motion. So we can say all the three objects are in uniform motion. But their slope is different. It means they are tilted in a different way. See, A is like this, A's graph, B's graph is this, and C's graph is this. Their slopes are different. It means what the slope of distance time graph gives? Speed. If the slopes are different, it means that they are in uniform motion, but they are moving with different speeds. So at least from graph you know that the three objects are in uniform motion, and as their slopes are different and as slope gives distance speed of the object, so three objects are moving with different speeds and their starting point is also different. For A it is 6.5 km away from origin, for B starts from origin, and for C it starts from 2 km away from the origin. Now let us have a look at this graph carefully. See, this is A graph and this is B graph. So here is the point where they meet. Here is the point of intersection of the two graphs. Means this is a point where A object and B object meet. Can we find the distance where they meet from the origin, or can we find what is the time when they meet? Yes, we can find. For that, what we can do is, we can drop a perpendicular from this point of intersection on x-axis, that is time axis, and see the time. So whatever time it comes, it means at that time or after that many hours, the two bodies A and B meet. And at what distance away from the origin? I can drop a perpendicular from this point of intersection on distance axis, and wherever it meets, that is the point of that is the distance away from the origin where they meet. Clear? Similarly, here A and C graphs meet at this point, and by drawing the perpendicular on time axis and distance axis, I can find out at what time or after how many hours do they meet and at what distance away from the origin do they meet. Okay? So this point of intersection will give me distance away from the origin. Clear? I hope you have understood this graph. We have studied the graph and now let us see the questions, okay, which are given. Now the first question or a question which they have asked is, which of the three is traveling the fastest? Now the three are in uniform motion, we have started. Their speeds are different, we know, because their slopes are different. Which is traveling the fastest? Whose speed is fastest? Whose speed is maximum? And who gives speed here? Slope of the graph. Now there is no need, they have not asked us what is the speed of the fastest object. Just they have asked which of the three is traveling the fastest. So I'll tell you, see, if you have a line like this, it means speed is 0, slope is 0. If the graph is like this, it means the speed is infinite, very, very large. In between, it depends on how much slope they have. If the bending is towards distance axis more, then the slope is maximum. The one which bends more towards the time axis, its slope or speed is least. So when we see the three graphs, see, for A object, this is a bend. For B object, this. For C, this. If you shift them parallel, like if you shift it parallel and bring it at O, and if you shift C parallel to itself and bring it at O, which is having the maximum bend towards distance axis? B. So B is having maximum slope and hence maximum speed. I know that at one instant just now you will not understand, but still you can find out the slopes also. And simple way is just to see which slope is bent more towards the distance axis. That is having maximum slope or maximum speed. So if they have not asked us to find out, there is no need to find out, but just see which is bent more towards distance axis. And from here we can say this B is bent more towards distance axis, so B is the fastest. Which object is traveling the fastest? B. So why is B traveling the fastest? Because slope of ST stands for distance time. Graph is maximum for B and so its speed is maximum because we know slope gives us speed. Now the next question, B part. Are all three A, B and C ever at the same point on the road? We have studied the graph before. Let us see. If they meet at any point on the road, it means the three graphs should meet at one point. Here we have B and C are meeting because the two graph intersects here. This is a point where A and B graphs meet. Again, only they two meet. This is a point where C and A object meet. So there is no point where the three graphs meet. So they never meet at the same point on the road. They have asked, are all three ever at the same point on the road? No. Why no? As the three graphs never meet at a point. Although they have not asked us why, but whenever the question is in the form of yes or no, wherever possible, we should mention the reason or we should justify our answer. Now C question is, how far has C travelled when B passes A? Now B passes A, let us see. B passes A. This is B's graph and this is A's graph and the two intersect at this point. How far has C travelled when B passes A? And I have already explained you before that by drawing a perpendicular, a dotted perpendicular on distance axis, we can find out the distance from the origin. Okay, but who has started from origin? B. Okay, so it means that is the distance travelled by B when they meet. But what is the question? How far has C travelled? So let us see how we'll do this. Now how far has C travelled when B passes A? So the two A and B meet at this point. You can name this letter and let us give a different letter here, D. Okay, we can give any letter here and name this point. Now I have dropped a perpendicular from this point of intersection of distance axis, and when I see, I have told you it is 4 divisions are there between 8 and 10 and it is just one division above 8 and value of one division is 0.5. Okay, so here this is 8.5. Okay, just wait. I have, just wait 1 second. Sorry here, actually the perpendicular was not drawn properly. It is actually 2 divisions above 8 and 1 division is 0.5. So 2 divisions above 8 means between 8 and 10, that is 9 kilometer. So when A passes B, okay, they meet at a point which is 9 kilometer away from the origin. Question is, how far has C travelled then when B passes A? Now C started from 2 kilometers away from origin. So 9 minus 2 is 7 kilometer. So when B passes A, C has travelled 9 minus 2, 7 kilometers. And the next question is, D is, how far has B travelled by the time it passes C? Now B's graph is this and C's graph is this. Where do they meet? The graphs meet at this point. So again we can find out the time by drawing a perpendicular from this on time axis. And suppose if they had asked question about the distance, then we can drop a perpendicular on distance axis. Now how far has B travelled by the time it passes C? So when B passes C at this point, to find out how far has B travelled, we can drop a perpendicular on this distance axis and find out the distance, as I'll explain you now. So from this point, I will drop a perpendicular on distance axis, and since it is one division above 4, so it is 4.5 kilometers. So I'll say B and C when they meet, I can name this letter also E, but it's not required here. We can name it B and C meet at point, let us say E. And how far has B travelled by the time it passes C? So a perpendicular is drawn here 4.5 kilometer and B has started from 0 only, origin only. So we'll say this distance is 4.5 kilometer. So by the time B passes C, B has travelled 4.5 kilometers. Okay, I hope you have understood this graph, but maybe you have to revise this lecture once again to understand it better. And remember, these perpendiculars are required. We will drop a perpendicular on x-axis or time axis when they ask at what time or after how many hours do they meet. But they have not asked us here, but you should remember, by dropping a perpendicular from this point of intersection on time axis, we can get the time after how many hours do the two objects meet on the road. Please revise this. This is a very important type of numerical based on graph. Now students, instead of starting with the 7th now, I am not continuing this with the 7th numerical. I am doing first 8th numerical. Reason is that 8th is also based on graph. So let us do the graph numericals first and then we'll do the other numericals. Now I'll read the question of this 8th numerical. The speed time graph for a car is shown in this figure. Okay, this is a speed time graph of a car. And in your NCERT textbook, you will see that it has the boxes like I have shown here. The entire this graph is having such type of boxes. It is having a graph paper like structure. How far? There are two parts of the question. A part is, find how far does a car travel in the first 4 seconds. I have written here the question. And also, shade the area in the graph that represents the distance travelled by the car during this period. B part is, which part of the graph represents uniform motion of the car. I'll read the question once again. Speed time graph for a car is shown. This is a speed time graph. First part is, how far does a car travel in the first 4 seconds? And we also have to shade the area on the graph which represents that what is the distance travelled by the car during this period. During this period means in first 4 seconds. And next is, which part of the graph represents uniform motion of the car. Now students, whenever you have graph based questions, okay, numericals, then you should first study the graph properly. So let us first study the graph properly and then we'll see what we'll try to find out the answer to the questions. Now this is speed time graph. Speed is given in meter per seconds, time is given in seconds. In your textbook this shading is not done, only this graph is given. Only this line is drawn, okay. Now, and the paper here is not blank in your textbook, it is having such boxes as you have on your graph paper. Then from the graph, let us study the nature of motion. See, first this is speed time graph and first this is a curve. It is not a straight line. It is a curve. It means it is not, here speed is changing but it is not changing at a uniform rate. Means first speed is increasing but it is not a case of uniformly accelerated motion, because for uniformly accelerated motion the speed time graph should be a straight line and it is not straight. We know that it is a case of non-uniform motion but not uniformly accelerated motion. Then we can see that after some time, approximately after this, for here till here, we can see that it is curved and the speed is increasing. First the speed is increasing more as the slope is more, then it is bending this way, so slope is decreasing. So here, the speed is changing at a faster rate first because the slope is more, and we know slope of speed time graph gives acceleration. So here it is increasing at a faster rate, then at a slower rate, and slowly we can see from here it is a straight line parallel to time axis. And when speed time graph is a straight line parallel to time axis, it means speed is constant and that is uniform motion. So we have seen the nature of motion of the car from the speed time graph, that initially the motion is non-uniform and also non-uniformly accelerated motion. Speed increases but not at a uniform rate. And after some time, let us say at about after 6 seconds, the graph becomes parallel to the time axis and we can say speed remains constant and then the motion becomes uniform motion. Okay, so we have seen the graph. Now, as I have told you, in your textbook, the graph has boxes like this and I have just copied the same thing here but only for small part of the graph. We can see here that 1, 2, 3, 4, 5. So on time axis, 5 divisions make 2. 5 divisions make 2 what? 2 seconds. So if we want to study the scale on x-axis, 5 divisions make 2 seconds. So 1 division is 2.5. This is seconds. 2.5 seconds only. Okay, that is 4.4 seconds. Let us try to make it simpler, students. On x-axis, 1, 2, 3, 4, 5. 5 divisions make 2 seconds. So 1 division is 2 by 5 seconds. No need to get the decimal places answer here. Similarly, on y-axis, this is a y-axis, 1, 2, 3. 3 divisions make 2 meter per second. 3 divisions make 2 meter per second. So value of 1 division is 2 by 3 meters per second. So from the graph, when we have such boxes drawn here, we can also find out the scale and value of 1 division on x-axis and on y-axis. Hope you have understood this. You will come to know soon why we have done this work. So, let us come to the question. If you have understood the graph properly, how far does a car travel in the first 4 seconds? As I have told you, this shading and this dotted portion is not given in the question. In the question only this was given. How far does a car travel in the first 4 seconds? We know that area under speed time graph gives us the distance travelled. So to find out the distance travelled in the first 4 seconds, what I have done, from 4 I have dropped a perpendicular. Okay, I have drawn a perpendicular at 4 which intersects this graph. So at 4 I have drawn a perpendicular on time axis only and I have seen where it intersects the graph. I have extended it till there. So now I know this area which is under the graph, okay, area under the graph represents the distance travelled. You can find out the distance travelled by various methods. One of the methods which you have studied in lower classes, let me explain you that. Now here, what we can do is, we can count the number of boxes under this area. In this area under the graph, we can count the number of boxes present in this area. Okay, if there are complete boxes, you can count them number of complete boxes. Then you can see near the edges, maybe there are boxes which are half. So you can count number of half boxes, number of complete boxes, or even if the box is here 3/4, if the box is 3/4, we can consider it as one box. If the box is very small part of the box is coming in this area, we can ignore it. Remember, we have to count the number of boxes in this area. So number of complete boxes, we can include all these boxes as well as the boxes which are lying near the edges inside it, but they are having area approximately 3/4 or more than 3/4 of the box. They will be considered under complete boxes. And half boxes, we can write number of half boxes. And the box which is having very small part included here, so we can ignore that. So we can count the number of complete boxes. Number of half boxes we can divide it by 2 to get the number of complete boxes, because 2 boxes will make 1 box. So in other words, if we calculate the total number of boxes in this area, and when I have counted, it is total number of boxes under the graph between 0 to 4 seconds is approximately 66. Your answer might vary with this little bit. Okay, that will be tolerated. Now, what is the distance traveled? Distance traveled is area covered by those 66 boxes, because 66 boxes are lying in this area, and area under the speed time graph gives us what? Distance traveled. So, distance traveled will be 66 boxes, 66 into area of 1 box. Now, what is area of 1 box? Just have a look at the scale. Area of box's length into breadth, and its length, if we consider along this time axis, it is 1 division is 2 by 5 seconds. So it is 2 by 5. 2 by 5 is at the side of one side of the box, into, if we consider the breadth to be along this speed axis, then here 1 division is 2 by 3 meter per second. It means area of 1 box is what? 2 by 5 into 2 by 3. Okay, so 2 by 5 into 2 by 3, that is the area of 1 box. 2 by 5 into 2 by 3, and we will get the answer in meters only. So distance traveled is 66 into area of 1 box, and approximately that comes out to be 17.6 meters. When you count the number of boxes, and maybe 1 or 2 boxes are less or more than this number, then you can get the approximate answer. Approximately it should be closer to 17.6 meters only. I hope you have understood this. But it is a very time consuming process. Now, B part. Which part of the graph represents uniform motion of the car? As we have already studied the graph before, that when the time is 6 seconds, after that the graph becomes straight line parallel to time axis. So, part of the graph from time 6 seconds to 10 seconds represents uniform motion, as speed remains constant during this time interval. I hope the 2 parts are clear to you, and also you can make this A part less time consuming by drawing this line. If you draw a straight line like this, okay, if you draw a straight line like this, you get a triangular shape. When you draw a straight line like this, you get a triangular shape, and you can find the area of that triangle. What is the area of triangle? Half into base into height. Half into 4 is a base and height is 6. So half into 4 into 6 will give you this area below this line, that is area of the triangle, and whatever area will be left here, it will be easier for you to count the number of boxes that, and so you can add this area of triangle to the number of boxes into area of 1 box. Again, you will get the same answer. Please listen to this again, okay, and repeat this. You can understand the second method also to find out how far the car has travelled in the first 4 seconds.